Hi, chapter 4 is all about working with congruent triangles, and what we're going to be doing over the next couple sections is trying to prove if two triangles are congruent to each other. So what we need to be able to do by the end of today is to name and label corresponding parts of congruent triangles, and then also kind of look at some congruent transformations that are available too. So when we talk about two congruent triangles, we're saying that these two triangles are the same exact shape and also the same exact measure. So if they are the same shape, then that means, and the same measure here, that means that these segments here they need to be corresponding. So if AB and XY are equal and BC and YZ are equal and AC and XZ are equal, we've got the three sides that are congruent. Now there's a little bit more to having congruent triangles, and they also have congruent angles. So angle B and angle Y would be congruent, angle A and angle X would be congruent, and then you'd have angle C and angle Z being congruent. And the congruence notation that we use is going to be the here where I have the two triangles, and then I'm saying that they're congruent to each other. And it's specific in the way that we write it out. And it all gets written out in a particular order because we use this later on to work with things as we're trying to prove if it's given to us that two triangles are congruent. And we use what's called CPCTC. Corresponding parts of congruent triangles are congruent. So from this one statement here that triangle ABC is congruent to triangle XYZ, we have 6 pieces of information that's actually telling us. And probably the easiest one to see is working with the angles. And from this statement, if triangle ABC is congruent to triangle XYZ, if I list A first in one triangle and X first in another triangle, what this is doing here is this is showing that angle A and angle X are congruent to each other if I write those out first. If I then follow it up with B and Y, this is telling me that angle B and angle Y are congruent to each other. And then if I follow that with angle C and angle Z, then angle C and Z are congruent to each other. So the order in which you write it out does matter. Then it gets to the sides. And how that works is kind of the same thing. If I list out A and B first, they're going to be congruent to sides X, Y. So I have A, B is congruent to X, Y. Then if I take the next two letters, so it would be the one in the middle and one at the end, so BC and YZ, this is showing me that those two segments are congruent to each other. Followed up by the third side, which would be the first and the last vertice, first and last. So AC or CA is congruent to ZX or XZ, however you want to write it out. And this is CPCTC. So if I take this and I use a congruent statement of triangle DOG is congruent to triangle CAT, I don't have the two triangles drawn out for me, but I can go ahead and list the 6 pieces of information just given the congruent statement that I have. So starting out with the angles, because D and C are both listed first, this is saying that angle D has to be congruent to angle C. Since O and A are the next listed angles, I can say that angle O is going to be congruent to angle A. And then since G and T are the last ones, angle G has to be congruent to angle T. So there are our 3 angles. Then I also have the sides that we can work from. So DO is the first side of one triangle, and the side that's going to correspond with that is going to be CA. It's the first 2 letters. The next side, which would be OG, and OG is going to correspond with the next 2 letters in CAT, so that's going to be AT, and so OG is congruent to AT. And then lastly, I'm going to take the first and last of each, so segment DG is going to be congruent to CT. And now I have my 3 sides. And so just from that one statement, you have 6 pieces of information that you can take from it. Now, when we're working with correspond or congruent triangles, we're talking about triangles that are staying the same shape and staying the same size. And we can have triangles move all over, and um, the size and shape stay the same. If you take a triangle and you just move it up, down, left, or right, that's called a translation or a slide or a shift. These two triangles here, they're staying the exact same. Nothing's changing on them, so they are congruent. They are congruent. If you did a reflection, if you flip something over, it doesn't change the size or the shape of it at all. It just changes its location. And so these two triangles are still congruent. If you rotate something, if you turn it and do a rotation, you're keeping the two triangles the same. And so again, they are going to be congruent. The only time that this does not hold true is if you do a dilation, which is a size change, and then the two triangles would not be congruent to each other anymore because they're going to change size. And that's when we would get into talking about similar triangles. So if you have a translation, a reflection, or a rotation, those are all transformations that end up being a congruence transformation. Over the next couple days, we're going to be spending a lot of time trying to prove if triangles are congruent. And all we're going to be doing today through this lesson is trying to verify that two triangles are congruent to each other. We just talked about how if two triangles have all the same sides, then you have congruent triangles. Well, so that's what we're going to be doing here. If I have two triangles that are listed out or drawn out on the coordinate plane, and I need to verify that verify each congruence and name the congruence transformation. What this is doing here is it's telling me to prove that these two triangles are congruent to each other. Now, when I look at the diagram, yeah, they look like they are, but in the world of geometry, we're trying to figure out how do we actually prove it. Yes, it's going to take a little bit of time, but you got to think of what can I show that I can be 100% sure that these two triangles are congruent to each other. So one of the ways we can do this is using our wonderful distance formula. Because if I can show that AB is congruent to A prime B prime, and AC is congruent to A prime C prime, and BC is congruent to B prime C prime, well then I can prove that these two triangles are congruent. And that's exactly what I did. So what I did is I used my distance formula 3 times to find the sides of triangle ABC and all the distances. And then I worked with all their primes as well. And we'll notice here that all of the sides match up. AB was equal to A prime B prime, BC was equal to B prime C prime, and AC was equal to A prime C prime. So the fact that I knew all of that right there, you have two triangles that are congruent to each other. Now, if I look to see what kind of transformation took place, did I move it? Did I flip it? Did I turn it? What I did here is it's really stayed in the same shape. There was no rotation. I just kind of moved it down and over, or I moved it over and then down. And so what we're doing here is we are doing a translation for a transformation. So we'll be looking at different ways of proving this, ways that you don't have to write it out, all the distance formula in the next couple days. But really what we need to be able to do is work with that CP/CTC and be able to come up with those 6 corresponding congruent parts. If you have any questions, make sure you write them down and ask them tomorrow.